Okay, welcome then to this lesson on measuring bearings between 180 degrees and 360 degrees. All right, you should have seen the video before this on measuring bearings from 0 degrees to 180 degrees. The link to that will be in the description below. Okay, so remember that a bearing is a way of measuring direction, and it's just an angle measured clockwise from a north line. But that was covered in the previous video. So just some quick examples, all right? And use the first one, okay? It just says measure the bearing from A to B. So again, I've got a bit of squared paper here, so you can follow along yourselves. I got this picture here, okay? And I put A roughly in the middle of the paper, and I got to find the bearing from A to B. So you should know that because we're going from A, you need your north line, which is a vertical line on the map, straight up, okay? A nice straight north line first of all. And now I want to go from A to B, okay? So we just join A to B, like we did in the previous video. And remember, a bearing must be measured clockwise, all right? So I'm looking for this angle here, this entire clockwise angle. But the protractor has to go like this because north is your 0, and we're using the outside numbers. Let me just focus the camera 2 seconds. Oh, that's much better, yeah, much better. So if you follow the outside scale around, you can see that you get the south and you run out of protractor. But that's fine. Like at the end of the previous video, just mark the fact that you've gone past south with a dashed line, like this, look. And then just measure the extra bit. This bit's 180 degrees, obviously. Starting, okay, half a circle. Turn it round. So we're counting again from 0. Yeah, from south though this time. See, from south. And follow around. I've got an extra 26 degrees here. An extra 26 degrees. So that was 180. And this was 26 degrees. Okay, so to work out the total bearing, and you would just do 180 degrees plus 26 more degrees, which is obviously 206 degrees. And that one is done. Okay. Next one then. Measure the bearing from A to C. And I should have said, sorry, if you are following along, that to get the point B from A, you had to go 1, 2, 3 centimeters left, and 1, 2, 3, 4, 5, 6 centimeters down. All right. If you want to follow along with shape with point C, that is 1, 2, 3, 4, 5, 6, 7. So 7 centimeters left, 1, 2, 3, 4, 5, 6, 7, yep, and 3 centimeters up if you want to follow along. Join A to C, and it's pretty obvious now. There's no need to put the protractor like this again, because we know we've gone past south, don't we? We know we're going to get past south. Okay, so I know that I've already got 180 degrees. So I just need to measure now, don't I? This extra bit here. All right, this extra bit here clockwise. So again, like this, nice and centered. Follow the outside scale around. Sorry, follow the outside scale around. Just get sorted. Yep. And I see that to get to point C, I've got about an extra 112 degrees, roughly. Yeah, like an extra 112 degrees. Okay, so this extra bit here is 112 degrees. And again, to find the total bearing, then you've got 180 already. And you've got an extra 112 degrees. So if you add those up, you get a total bearing of 292 degrees. Done. Okay. And the last example is to measure the bearing of A, but from D. We're going from D, so that means your north line needs to be a D. Okay, we're going from D. Watch the mistake people make. We're going from D. See? of A from D. So I've got to get to A, which I will. It's only a short hop here. Okay. And I have to measure this entire clockwise angle. Well, again, obviously I'm going to go past south, aren't I? You can see. So this here is 180 degrees already. And then let's measure the extra bit. All right. To the pink line here going to A. So start from, let me get it bang on. Start from this outside zero again and count around. And I've got about an extra 82 degrees, I would say. About an extra 82 degrees. All right, so if I take this again, then I add 180 degrees. I'm adding on 82 more degrees. So I should get a total bearing of 262 degrees. Okay, and that one's done. So these bearings are easy. Just make sure you think about it, all right? Draw your north line in the right place. Always go clockwise from north and always use the outside scale. Okay, right, so again, should I have mentioned actually, sorry, if you want to follow along, my bad, keep doing this, that from A to D, you had to go 1, 2, 3, 4, 5, 6 squares right and 1 square up, okay, if you wanted to follow along. But hopefully you counted the squares if you had to anyway, okay? Right then, for the checking question, just a quick checking question here. This one says sketches only, so no protractors allowed, all right? I'm going to put mine to one side and get my tablet, again, center stage. So take a look at this one, and let's think how we can answer this one. All right, I'm going to put it over the screen as well. So point B is on a bearing of 0.56, so 56 degrees from point A. Right, so from point A, let's say that's here, point B is on a bearing of 56 degrees. So where would that be roughly on a sketch? Well, if we draw our north line at A, and I'll do my best here, it's difficult on the screen, then I hope you see that 56 degrees would maybe be like over here somewhere, because it's less than 90 degrees, and 90 degrees would take you here, wouldn't it? It would take you across to the easterly direction, but it's less than 90, so it's going to be here somewhere roughly. Call that point B. And again, it's only a sketch, all right? So don't laugh at this dodgy straight line. Here you go. That's the sketch, and I require this clockwise angle here. Sorry, I don't need that, do I? I know what that is, sorry. All right? This angle here, I'm told this angle here is 56 degrees. Okay? Perhaps I could just drag this down a little bit to make it a bit less cluttered. I can, that's good news. So I put this on the picture here, okay? All this is on the picture now. What's the bearing of point A from point B? Right, so remember, from point B means I need a north line at B now if I'm going from B for the second part of the question. So, here you go. So the bearing in it would be this here, this clockwise angle here. That's what I need. So how would you get that without measuring with a protractor and drawing stuff with the protractor? Well, think back to your work you've done on parallel lines. I hope you agree that these two north lines both point vertically upwards. So they're parallel lines, okay? And you hopefully recognize a key fact about parallel lines from before, that if ever you see this sort of C shape here, I know it's rotated, but you have got a sort of C shape here. Remember, these angles here are called allied angles. And the key fact about those is that they always add to 180 degrees. So see this purple angle and 56, they're allied angles. So they must add to 180 degrees. That's a key parallel facts rule, parallel lines fact rule you should know, okay? So to get the purple angle, you just do 180, take away 56 to see what's left over, okay? And that gives you 124 degrees due to allied angles. I wouldn't call it a C angle, all right? It looks like a C, but the proper name is an allied angle. So that's 124 degrees. And then how would I get my required bearing, which is this big blue angle here? Well, common sense, right? There are 360 degrees in a full turn. So to find the bearing, I would just do 360 degrees minus the 124 degrees. And then you will get your answer. Okay, so 360 take away 124 is 236 degrees. Okay, and because we drew quite a good sketch, it even looks right to me, because obviously it's bigger than 180 degrees, because that would be here, but it'd be less than 270 degrees, because that would be due west. So if you draw a good sketch and think about it, and remember this key rule here, okay? Allied angles always add to 180 degrees. You can answer these problems quite easily. So we're all done. So thanks for listening. Thanks for watching. Take care. Stay safe. See you soon. Nice one.